Now in this question we need to evaluate 0 to pi by 2 secant theta into tan inverse of a cos theta d theta, and while applying u into v, that is a product of integrals, this becomes quite a lengthy problem. So how do we avoid that? Yes, one important procedure here is integral 0 to pi by 2 secant theta into tan inverse of a times cos theta d theta. This is a function of theta, integral with respect to theta, and being substituted the values upper limit pi by 2 and lower limit 0. So shall we say this integral would be a function of a finally, right? So what we do is, we'll consider the given integral to be IA, which is a function of a. Now let us see what is the advantage of considering this function as a function of a. Can you write what is I dash a now? Differentiating this I of a with respect to a here, this integral is unaffected because this is a function of theta. So integral 0 to pi by 2 secant theta into, which is a constant. As a is present inside tan, this gets differentiated. So 1 plus a square cos square theta into derivative of a cos theta is cos theta d theta, cos theta into secant theta 1. So this is integral 0 to pi by 2 1 by 1 plus a square into cos square theta d theta. Now to make the integration more comfortable, let's express this cos square theta as 1 by secant square theta and see what will happen to this integral. 0 to pi by 2 secant square theta by secant square theta plus a square d theta. So I dash a, we separated the value of a square. Yes, now we are on the right track. 0 to pi by 2 secant square theta d theta by the denominator secant square theta, we will express this as 1 plus tan square theta plus a square. Now this integral can be easily calculated when we put t as tan theta, then dt becomes secant square theta d theta. Not only this, as theta tends to 0, even t tends to 0, and as theta tends to pi by 2, the value of t tends to infinity, tan 90. So how does the new integral value changes to? This is integral 0 to infinite dt by 1 plus a square as a constant plus t square. Now this is in the form dt by k square plus t square. Can we integrate this? Yes, this is 1 by root of a square plus 1 times tan inverse of t by root of 1 plus a square, and the integral is evaluated between 0 to infinity. Now as the upper limit this is pi by 2 and the lower limit this is 0. So how much is this value? This is pi by 2 times root of 1 plus a square. But remember, we are evaluating I dash a, but we need to calculate I of a. Then what would be I of a now? I dash a's integral, so that would be pi by 2 constant integral 1 by square root of 1 plus a square dA, right? This is nothing but pi by 2 times ln of a plus root of 1 plus a square plus c. Now we need to evaluate the value of c. This we can clearly calculate because I of 0 would be integral 0 to 0 some function, that means it should be 0. Therefore c value would be clearly 0. Now c is 0, therefore what is I of a? Pi by 2 times ln of a plus root of 1 plus a square. Let's verify which option is satisfying. Yes, the value of IA, that is a given required integral, is pi by 2 times ln of a plus root of 1 plus a square.